Hello children, in this today's video session, we are going to start Unit 4 Electric Charge and Electric Current. In this lesson, we will study about electric charge, electric current, electric circuit diagram and effects of electric current. Come, let's get into this video session.
Hello children, today we are going to learn Unit 4 Electric Charge and Electric Current. In this lesson we are going to learn about the electric charge, electric field and Coulomb's law and the concept of electric current, voltage, resistance and Ohm's law, and to draw the electrical circuit diagrams for series and parallel circuit. Then the effects of electric current like heating, chemical effect and magnetic effect, and DC and AC currents, that is direct and alternating currents, and then the safety aspects related to electricity. Like mass and length, electric charge also is a fundamental property of all matter. We know that matter is made up of atoms and molecules. Atoms are made up of subatomic particles like electrons, protons, and neutrons. Where these particles present in an atom? Protons, neutrons present inside the nucleus of the atom, and electrons, which is negatively charged, revolve around the nucleus of the atom. By nature, electrons and protons have negative and positive charge respectively, and neutrons do not have charge. Electric current consists of moving electric charges. So, electricity is an important source of energy in the modern times. Come, let's learn what is electric charge. So, what is electric charges? Electric charges are made up of positive charges protons and negative charges electrons. When these charges flow in a circuit, a current is produced. If an electron is removed from the atom becomes positively charged. Then it is called as a positive ion. If an electron is added in excess to an atom, then the atom is negatively charged and it is called as a negative ion. What will happen when you comb your hair on a dry day? The comb obtains power to attract small pieces of paper, isn't it? When you rub the comb vigorously, electrons from your hair leave and accumulate on the edge of the comb. Your hair is now positively charged as it has lost electrons, and the comb is negatively charged as it has gained electrons. So that comb obtains power to attract small pieces of paper. Measuring electric charge. Children, we already know that for length we are using the unit meter, kilometer and all, okay, and for time seconds, hours, and then for mass is kilogram. Like same way, electric charge also is measured in coulomb and the symbol for the coulomb is C. The charge of an electron is numerically a very tiny value. The charge of an electron, represented as E, that is small e, is the fundamental unit with a charge equal to 1.6 into 10 to the power minus 19 coulomb. C represented as coulomb. This indicates that any charge is Q. Okay. Any charge has to be an integral multiple n of this fundamental unit of electron charge E. That is, charge is equal to n into E. N is the whole number and E is the watt electron charge. Practically, we have mu coulomb, that is micro coulomb, NC, that is the nano coulomb, and PC is the picocoulomb as the unit of electric charge. 1 microcoulomb is equal to 10 to the power minus 6 coulomb. 1 nanocoulomb is equal to 10 to the power minus 9 and 1 picocoulomb is equal to 10 to the power minus 12 coulomb. Electric charge is additive in nature. The total electric charge of a system is the algebraic sum of all the charges located in the system. For example, let us say that a system has two charges plus 5 coulomb and minus 2 coulomb. Then the total or net charge on the system is plus 5 coulomb plus minus 2 coulomb is equal to plus 3 coulomb. Now we'll come to the topic electric force. Among electric charges, there are two types of electric force. One is attractive and the other is repulsive. The like charges repel and unlike charges attract. When you will see this image, we can able to understand. Okay, like charges means same charge, that is for positive charge. Okay, so it what always repel and negative also repel. So these all what like charges always repel. Unlike charges, for example, positive and negative, unlike charges always attract. So the force existing between the charges is called as what? Electric force. These forces can be experienced even when the charges are not in contact. So when like charges or repel and unlike charges or attract. What is electric field? The region in which a charge experiences electric force forms the electric field around the charge. Where this electric field forms? Around the charge. Often electric field E is represented by lines and arrowheads indicating the direction of the electric field. So electric field is represented by E by the lines. Okay, electric field is E represented by lines and arrowheads what is the direction of electric field. The direction of the electric field is the direction of the force that would act on a small positive charge. Therefore, the lines representing the electric field are called electric lines of force. In the image 1, we can able to see that isolated positive charge, the electric lines of force are radially outwards. Okay, the direction is what? In the outward direction because of positive charge. In the second image diagram, we can see that isolated negative charge, they are radially inwards because of the negative charge. Okay, so the electric field at a point is a measure of force acting on a unit positive charge placed at that point. So a positive charge will experience force in the direction of electric field and negative charge will experience in the opposite direction of electric field. Electric potential. Though there is some electric force, either attractive or repulsive force, existing among the charges, they are still kept together, is it not? We now know that in the region of electric charge, there is an electric field. Other charges experience force in this field and vice versa. There is a work done on the charges to keep them together. This results in a quantity called electric potential. So what is electric potential? Electric potential is a measure of the work done on unit positive charge to bring it to that point against the electrical force. So now you can able to see in this image lower electrical potential energy is moved to higher electrical potential. What is electric current? When the charged object is provided with a conducting path, electrons start to flow through the path from higher potential to lower potential region. Normally, the potential difference is produced by a cell or battery. When the electrons move, we say that an electric current is produced. That is, an electric current is formed by moving electrons. Direction of current. Before the discovery of the electrons, scientists believed that an electric current consisted of moving positive charges. Although we know this is wrong, the idea is still widely held as the discovery of the flow of electrons did not affect the basic understanding of the electric current. The movement of the positive charge is called as conventional current. The flow of electrons is termed as electron current. This is depicted in the figure electric current. In electrical circuits, the positive terminal is represented by a long line and negative terminal as a short line. Battery is the combination of more than one cell. Measurement of electric current. We can measure the value of current and express it numerically. Current is the rate at which charges flow past a point on a circuit. That is, if Q is the quantity of charge passing through a cross section of a wire in time t, quantity of current I is represented as I is equal to Q by T. Here I is the current and Q is the charge, T is the time. The standard SI unit for current is ampere with the symbol A, capital A. Current of I ampere means that there is 1 coulomb of charge passing through a cross section of a wire every 1 second. So 1 ampere is equal to 1 coulomb of charge by 1 seconds, that is time. Or we can write it as a 1A is equal to 1C by 1S. So students, which instrument we are using to measure the electric current? That is ammeter. Ammeter is an instrument used to measure the strength of the electric current in an electric circuit. So the ammeter is connected in series in a circuit where the current is to be found. The current flows through the positive red terminal of ammeter and leaves from the negative black terminal. Electromotive force, that is e.m.f. Imagine that two ends of a water pipe filled with water are connected. Although filled with water, the water will not move or circle around the tube on its own. We all know this. Suppose you insert a pump in between and the pump pushes the water, then the water will start moving in the tube. Now the moving water can be used to produce some work. We can insert a water wheel in between the flow and make it to rotate and further use that rotation to operate machinery. Likewise, if you take a circular copper wire, it is full of free electrons. However, they are not moving in a particular direction. You need some force to push the electrons to move in a direction. The water pump and a battery are compared. Devices like electric cells and other electrical energy sources act like pump pushing the charges to flow through a wire or conductor. The pumping action of the electrical energy source is made possible by the electromotive force, that is e.m.f. The electromotive force is represented as epsilon. The e.m.f of an electrical energy source is the work done W by the source in driving a unit charge Q around the complete circuit. So electromotive force is equal to work done per charge, that is W by Q. Where W is the work done, the SI unit of electromotive force is joules per coulomb or volt. In other words, the EMF of an electrical energy source is 1 volt if 1 joule of work is done by the source to drive 1 coulomb of charge completely around the circuit. What makes the electric charges to flow? Actually, charge do not flow in a wire by themselves. Why? Let us consider the flow of water in a horizontal tube. Water does not flow. If we connected one end of the tube to a tank in the water kept at higher level, due to pressure difference between two ends of a tube, water flows out of the other end of the tube. Similarly, the electron move for a flow of charge in a conductor if there is a difference of electric pressure called potential difference. This difference produced by a battery or cell. The chemical reaction within a cell produced potential difference across the terminal of a cell. When the cell is connected to a conducting circuit, the potential difference sets the charges in motion in conductor and produces an electric current. The potential difference is represented by the symbol V. So V is equal to W by Q, where W is the work done, the amount of electric energy converted into other forms of energy measured in joule, and Q is amount of charge measured in coulomb. The SI unit for both EMF and potential difference is the same, that is volt V. Do you know which instrument we are using to measure the potential difference? That is voltmeter. Voltmeter is an instrument used to measure the potential difference. To measure the potential difference across a component in a circuit, the voltmeter must be connected in parallel to it. Say you want to measure the potential difference across a light bulb, you need to connect the voltmeter. The positive red terminal of the voltmeter is connected to the positive side of circuit and negative black terminal is connected to the negative side of the circuit across a component. Next, resistance. What is resistance? Let's see the image and to understand clearly what is resistance. Why we are using tap to control the flow of water? We are using tap. Okay, if you want more water, you will release the tap. If you want less water means you'll close the little bit. You will close the tap. Okay, like the same way in the electric current in the electric circuit we have a resistor. Okay, this resistor why we are using means to slow down, otherwise to control the flow of current we just using this resistor. Okay, we can able to see in this image different resistor, okay, and the symbols. Okay, so this is the resistor symbol. Why we are using this resistor means to slow down or to control the overflow of what electric current. Let's see the electric circuit diagram. In this electric circuit, the positive terminal of the battery is connected to the resistor and another end of resistor is connected to the ammeter negative and ammeter positive to key, other end of key to battery negative. Okay, so in this circuit the resistor is connected. Why we are connecting resistor? Because it controls the flow of current. Okay, so if the resistor is more, that means R is inversely proportional to I. Okay, if the resistance is more, there will be a less current. If the resistance is less, there will be a more current. Okay, so what is resistance? The resistance symbol is R, is the measure of a portion offered by the component to the flow of electric current through it. Different electric components offer different electrical resistance. Metals like copper, aluminum, steel, etc. have very much negligible resistance. That is why they are called good conductors. On the other hand, materials like nichrome, tin oxide, etc., offer high resistance to the electric current. We also have a category of materials called insulators. They do not conduct electric current at all. Glass, plastic, polymer, rubber, cloth, wood, and paper. All these materials are needed in electrical circuits to have usefulness and safety in electrical circuits. The SI unit of resistance is ohm with the symbol ohm. 1 ohm is the resistance of a component when the potential difference of 1 volt applied across the component drives a current of 1 ampere through it. We can also control the amount of flow of current in a circuit with the help of resistance. Such components used for providing resistance are called as resistors. The resistors can be fixed or variable. The first symbol is fixed resistor and second one is variable resistors and the third one is rheostat. Fixed resistors have fixed value of resistance while the variable resistors like rheostats can be used to obtain desired value of resistance. Electric circuit diagram to represent an electrical wiring or solve problem involving electric circuits, the circuit diagrams are made. The four main components of any circuits, namely cell, connecting wire, switch, and resistor or load, are given above. Okay, if you see the circuit diagram, what are the things is connected in the circuit? Cell, positive terminal, negative terminal, and positive terminal of cell is connected to the switch by using connecting wire. Okay, other end of the switch is connected to the resistor and other end of resistor is connected to the negative terminal of the cell. So four main components we need to connect what simple diagram. Connect the components is called cell, connecting wire, switch, resistor. Okay, these are the electric circuit and four main components of circuits. Okay, let's see the common symbols in electrical circuits. First device is that switch and the symbol is given in that. Okay, we can use first symbol or otherwise second symbol. Next one is cell. Okay, positive terminal and negative terminal. Longer line represented positive terminal, shorter line represented negative terminal. And battery, if we connected more than one cell, that will say it is what? Battery. So more than one longer line will draw on the symbols. And next one is the DC power supply, that is direct current, and then AC power supply, alternative current. Next, light bulb, potentiometer, light dependent resistor, LDR, wires joined, wires crossed, fixed resistor, variable resistor, rheostat, fuse, coil of wire, transformer, semiconductor diode, galvanometer, ammeter, voltmeter, two-way switch, earth connector, capacitor, thermistor, bell. For galvanometer, ammeter, voltmeter, the first letter is represented in the symbol. Okay, for example, galvanometer first letter G. So, capital G represented in the symbol. Ammeter first letter A. In the symbol, A is represented. Okay, and voltmeter is V. Okay. Different electrical circuits. We have two different electrical circuits. One is series circuits, another one is parallel circuits. Let us first look at the current in a series circuit. In a series circuit, the components are connected one after another in a single loop. In a series circuit, there is only one pathway through which the electric charge flow. From the above, we can know that the current I all along the series circuit remains same. That is, in a series circuit, the current in each point of the circuit is same. In parallel circuit, the components are connected to the e.m.f source in two or more loops. In a parallel circuit, there is more than one path for the electric charge to flow. In a parallel circuit, the sum of the individual current in each of the parallel branches is equal to the main current flowing into or out of the parallel branches. Also, in a parallel circuit, the potential difference across separate parallel branches are same. Effects of electric current. When electric current flows in a circuit, it exhibits various effects. The main effects are heating, chemical, and magnetic effects. When the flow of current is resisted, generally heat is produced. This is because the electrons, while moving in the wire or resistor, suffer resistance. Work has to be done to overcome the resistance, which is converted into heat energy. This conversion of electrical energy into heating energy is called Joule's heating, as this effect was extensively studied by the scientist Joule. This forms the principle of all electric heating appliances like iron box, water heater, toaster, etc. Even connecting wires offer a small resistance to the flow of current. That is why almost all electrical appliances, including the connecting wires, are warm when used in an electric circuit. Caution: the heating effect and the chemical effect experiments have to be performed only with a DC cell of around 9 volt. Students at any cost should not use the main domestic electric supply, which is a 220 volt AC voltage. If it is used, it will give a heavy electric shock, leading to a severe damage to our body. So far, we have come across the cases in which only the electrons can conduct electricity. But here, when current passes through electrolyte like copper sulfate solution, both the electron and the positive copper ion conduct electricity. The process of conduction of electric current through solution is called electrolysis. The solution through which the electricity passes is called electrolyte. The positive terminal inserted into the solution is called anode and the negative terminal cathode. Magnetic effect of electricity. This tells direction of current and magnetic field. Okay, a wire or a conductor carrying current develops a magnetic field perpendicular to the direction of flow of current. This is called magnetic effect of current. Here says always the current flows is perpendicular to the direction of magnetic field. So this what scientists Orested discovered, and right hand thumb rule are detailed in this chapter on magnetism and electromagnetism in this books. So direction of current is shown by the right hand thumb and the direction of magnetic field is shown by other fingers of the same right hand. Types of current: direct current, that is DC, and alternating current, that is AC. Direct current. We know current in electrical circuits is due to the motion of positive charge from higher potential to lower potential or electron from lower to higher electrical potential. Electrons moves from negative terminals of the battery to positive terminal of the battery. Battery is used to maintain a potential difference between the two ends of the wire. Battery is one of the sources for DC current. The DC is due to the unidirectional flow of electric charges. Some other sources of DC are solar cells, thermocouples, etc. The graph is depicting the direct current is shown in the figure. So many electronic circuits use DC. Some examples of devices which works on DC are cell phones, radio, electric keyboard, electric vehicles, etc. Alternating current. If the direction of current in a resistor or in any other element changes its direction alternately, the current is called an alternating current. The alternating current varies with time. This variation is characterized by a term called as frequency. What is frequency? Frequency is the number of complete cycle of variation gone through by the AC in 1 second. In AC, the electrons do not flow in one direction because the potential of the terminals vary between high and low alternately. Thus, the electrons move to and fro in the wire carrying alternating current. It is diagrammatically represented. Okay, so the electrons do not flow in one direction in the alternating current. So the waveform of AC image is given here. Domestic supply is in the form of AC. When we want to use an electrical device in DC, then we have to use a device to convert AC to DC. The device used to convert AC to DC is called rectifier, and the symbols used in AC and DC circuits are given in this. Okay, DC voltage circuit symbol, AC voltage circuit symbol for DC, AC, okay, and AC, DC, the same symbol representing. Advantages of AC over DC. The voltage of AC can be varied easily using a device called transformer. The AC can be carried over long distances using step-up transformers. The loss of energy while distributing current in the form of AC is negligible. Direct current cannot be transmitted as such. The AC can be easily converted into DC, and generating AC is easier than DC. The AC can produce electromagnetic induction, which is useful in several ways. Advantage of DC current. Electroplating, electrorefining, and electrotyping can be done only using DC current. Electricity can also be stored only in the form of DC. Dangers of electricity and precautions to be taken. The following are the possible dangers as far as electric current is concerned. First one, damaged insulation. The outer layer of insulation is used to prevent contact of the skin and the electrical wire. The outer layer could be damaged, which could thus harm the user. Overheating of cables. Due to excessive current flowing in the wire, the cable could overheat, the insulating layer could melt and emit poisonous fumes and even catch fire. Damp conditions. We have to avoid using damp or wet conditions because water is an electrical conductor. We have to make sure our hands are dry, otherwise, the live current will run through us and could be fatal. Beyond the reach of children, the electrical sockets are to be kept away from the reach of little children who do not know the dangers of electricity. Thank you, children.